So let's try this out. How would we create a function to delete a given die? What we're going to have to do is we're going to have some kind of set state operation. And the thing we're going to do is we can just use for now the actual index. And we need to be able to delete the die with a given index. If you want, you can try this out yourself. Think about how you would write the set state to delete a die. You can write it as const handle delete and then deal with that. And then we would need to pass it into the DieDisplay so that when this button gets pressed, we can actually remove it from state. So think about that for a second, and I will slowly go through it. And if it sort of gives you inspiration of how you would finish it out at any point, I encourage you to take it over and try it out for yourself. First thing is, if we're going to take another function in the DieDisplay, we have to add it to our props. So we need to take a handle delete is going to be a function, and it's not going to return anything, so it's just going to be of type void. But we need to be able to differentiate which die in particular we want to delete. For that, we can just use the index within the array. So we can say that it's going to take an index, which is going to be a number. Then we can actually destructure it here, handle delete, get the index, and then when this is clicked, on click, we are going to handle delete for the given index, like so. That's the only change that we need to write in the DieDisplay. But then in our app.tsx, we have to actually create the handle delete function. So this is going to take an index number, and then we can say handle delete equals handle delete. And now we need to write the set state operation to remove an index from the array. So think about that for 1 second, how you could do it. One little hint, use that filter function from earlier. You can use the filter function, and inside of the set dice state handler, you can use the previous value of the state. So think about it. If you get stuck, we can say set dice, take in our previous dice and the index. Wait, is that getting a little ahead of myself? Just take the previous dice and return previous dice dot filter. And the condition, we don't need to take in the value, but we get the value and the index. And we return true to include this dice if, we should actually have this be something named different. Say die index, return true if index is not equal to die index, like so. So breaking this down, it's going to filter out the previous state values and get rid of the one in which the index equals the die index. So now let's try this out. Can delete, add something new, hello, add die, and then delete it, just like so. Works beautifully. One other little convention is if you ever need to destructure some property and it's not used. So in this case, as we're filtering the dice, we only care about the index. We don't care about the actual value on the dice. Just put a little underscore in front of it. And that says, hey, we're deliberately not using this as opposed to accidentally not using this. So there you go. We wrote a state handler to, again, handle some complex state and deal with this array and filtering out to remove the die with the given index. Now we've covered everything that you need to finish out the implementation of our dice roller as it currently exists. There's only 3 things left to do. First is we need to declare some state to store our die results so that we're not importing the static data. We need to handle what happens when we click the roll button, and we need to handle what happens when we click the clear button. I'm going to walk through implementing all 3 of these things really quickly, but I would highly recommend trying at least a few of them yourself to check your understanding, because to do all 3 of these things, we don't have to cover any new concepts. So first off, setting up some results state. Similarly to how we have our dice state, we can say results and set results. Set results are going to take in, or are going to be of the die result array. Die result array. And then we can pass that in instead of doing sample rolls. Actually, this is going to be a 2-dimensional array. I lied. So for example, we could say results instead of sample rolls. Results and results dot length. So that works. And then for the roll result, there's nothing at all we need to change because handling the roll and the clear is all going to happen up here. So there, that is step 1. For handling our roll, what we're going to do is for every die in our dice, we're going to calculate a random roll and then add it to our results array. So it's going to be a little bit complicated, but we can break it down. We can say const handle roll. It's not going to take anything in except for the dice state, and we can just use that dice state directly. So what we need to do is we need to create a new die result array, which we're going to append to the results 2-dimensional array. So we can say const round results is an empty array of type die result array. Then we're going to loop through each dice in the set dice. So we can say for const die of dice, like so, and each one of these is going to be an individual die. We need to get the random roll result. To do that, say const result equals math.random. This is going to get us a random number between 0 and 1. Then in order to make it between 1 and our actual sort of max value of the die, so for example, if we wanted to make this between 1 and 6, we could say math.random times 6. This would make it, instead of between 0 and 1, 0 and 6. And then we can say math.ceiling, math.ceil which is just going to take the ceiling. So we have our result, which is going to be the ceiling of our number between 0 and really 5.9999. So this is going to give us an integer between 1 and 6, although instead of 6, we want it to be die.sides. Then what we need to do is just add it to our array. So we can say round results dot push a new object, which is going to be the value of our die, and then also a result of just result. If your property is named the same, you can just pass it like this as shorthand for result, like so. And we know that because we don't get any type errors. Finally, we can just set results to, again, our pattern for adding something to the end of the array. We're going to take the previous and return the previous, and then the new round results, like so. Now we can try binding this to the roll button. On click is going to handle roll and see if this works. So just make sure we're all cleared. Add a new die, add die, add die, and then roll. And there we go. We get, I guess, a little bit of an issue because our second die doesn't have a name, but one of the die got 3 out of 6, the other got 1 out of 6 for a total of 4 out of 12. We can delete that die that doesn't have a name and say it's die 2. Add die, roll, and then our next roll. It looks like they're going in the wrong order. So we can, it looks like we're flipping them here. So we can instead switch these. And then, clear doesn't work yet. So add die, die 2, add die, roll, roll. There we go. Now they're going in the correct order. Each newest roll is on top, and we have our whole roll history going down there. So that is handle roll. Now finally, handle clear is going to be pretty simple. You can just say handle clear. All it's going to do is set results to be an empty array again. So then we can bind it here. On click is going to handle clear. And there we go. That is 2 and 3 done. And now we have a completely functional, except for the data persistence after refreshes, but we'll do that in a bit, completely functional die roller. We can add our die, die 2. They can be any number of sides. Well, any number of sides with a minimum of 2. Add die, can do a bunch of rolls, and then when we're done, we can clear them, just like so. So there you have it. That is the interactivity. We can now completely delete this sample data because we're not using it. And now you have a dice roller. Congratulations. That you can count as, a slightly more complicated project than just a hello world. But as you can kind of already tell, there's a couple finishing touches we might want to put on this. And there's also a better way that we can manage all of this different state handling, which we'll talk about in a second.